Okay, so hello everyone. This will be my first video on the IB Biology SL tutoring series. Today I'll be covering topic 1.1, or better known as water overall. I will be covering SL content, and my partner tutor Enzo will content. So you can find his videos right under this one. So let's begin. Water is considered the medium of life because every cell is surrounded by it and most biochemical reactions occur in it. Water is the medium of life and it has many functions. For example, as I just said, it does biochemical processes, for example, cell respiration. It helps in obtaining nutrients. It helps in the removal of waste products. And it has a unique ability to sustain life. Now, life began in water as cells are formed in watery environments. And there is this common theory that the first cells likely evolved in the ocean. Water dissolves solvents. I will come back to this later. However, you need to know that this allows for diffusion, osmosis, and metabolic reactions, which you will learn throughout the course. Let's actually look at water though. Water is made of a negatively charged oxygen atom and two positively charged hydrogen atoms. And this is how one water molecule will look like. Now, water is a molecule made up of atoms, two hydrogen, one oxygen, what I just showed you here. Between these atoms, there is this intermolecular force. You see these forces? This is kind of holding them together. And these are called polar covalent bonds. Now, this is a very complicated word at first. That's what it seems like, at least. You don't really know any of these terms, but I'll teach you this. Polar. What does polar mean? It is important that you will remember what I'm about to say because polar or polarity occurs all throughout this IB biology course. So you really have to understand the concept of polarity right now. So the polar means that there's an unequal sharing of electrons in a covalent bond leading to slightly charged areas. Okay, now you may ask, what's a covalent bond? Covalent means that they are made of or made by sharing of electrons between atoms. So a covalent bond will be when two atoms, let's say atom X, shares electrons with atom Y, right? That would be a covalent bond when they share electrons. Now, a polar covalent bond is when they share electrons, but this sharing is unequal. Now, why is this sharing unequal though? And this is simply to answer. Since oxygen is slightly more negatively charged and hydrogen is slightly more positively charged, the oxygen will kind of pull the electrons a bit stronger, so causing that unequal sharing. You can think of it like a game of tug of war. On the one side, there's this really tall and big giant, while on the other side, there's these two normal men. You know, the big giant is going to pull the rope a bit stronger than the hydrogen atoms, which are in this case the men. Okay, now, hydrogen bonds and polarity. Hydrogen bonds as a consequence of the polar covalent bonds within water molecules. Water molecules are polar because oxygen pulls electrons stronger than hydrogen. This is what I just said. Oxygen pulls this electron stronger. Remember the tug of war. So, between the oxygen and the hydrogen, there will be this intermolecular force called a covalent polar covalent bond because it is the sharing of electrons between two atoms, but it is an unequal sharing. Okay, now, since water molecules are polar, they attract each other using hydrogen bonds. Look, this is a water molecule, and this is also a water molecule. Remember what I just said, that there is these bonds between atoms of the same molecule, now there's this new bond introduced between the oxygen of one molecule, one water molecule, with the hydrogen of another water molecule. Now, this hydrogen bond is a weak attraction between a positively charged hydrogen, what we see right here, and a negatively charged oxygen from different or neighboring molecules. And this causes, since this is a water molecule, this is a water molecule, this causes water to stick together, for water to actually like become a lot. This is going to connect to another water molecule, which has hydrogen, hydrogen, and this is also going to connect, blah, blah, blah. You see how that will keep on going for many, many times. Now, the covalent bond between an atom and a hydrogen atom, this bond right here, the polar covalent bond, is extremely strong. So to break this bond between two atoms is very hard because there's a strong attraction of atoms in the water molecule. Now, the hydrogen bond of different water molecules is weak in comparison to this, and it is easier to break. Okay, that's it for A1.1.2. Now, we'll go to A1.1.3. This talks about cohesion. Cohesion occurs when water molecules stick to each other. This is what I just explained. This water molecule sticks to this water molecule through the hydrogen bonds, which is a weak attraction between the positive hydrogen and the negative oxygen of different molecules, blah, blah, blah. Now, this happens due to hydrogen bonding. And this is important for things such as surface tension and the transport and xylem, which you will learn in a future unit. Now, for 1.1.4, this talks about adhesion. Now, cohesion is when water sticks to water. Adhesion is when water sticks to other materials. For example, you spill water on your table, you know how that kind of sticks to the table? That's exactly adhesion. Water sticking to molecules that are polar or charged and impacts, ignore this. Now, adhesion aids in capillary action, which is water moving up narrow tubes. You will learn this later along bio. Like plant cell walls using capillary action. And water clings to cellulose in plant cells, blah, blah, blah. This you will learn later again. Just know for now that adhesion is kind of water sticking to materials that are polar or charged that are not water. Now, you need to know cations and anions as well. Me personally, in my IB bio history, I have not seen any questions talking about cations or anions, but it is in the syllabus, so I would recommend just to know it. A cation is a positively charged ion. This means that negative electrons leave the ion, which make it more positive. If you have a room with a bunch of negative people, if all these negative people leave the room will kind of become more positive. I hope that makes sense. And for an anion, it's the other way. If more negative people come into the room, that makes it more negative, so it's a negative charged ion. Now, what I mentioned earlier about water dissolved solvents, I will talk about now. Water has solvent properties, and this is linked to its role as a medium for metabolism and for transport in plants and animals. Water is a universal solvent. This means it can dissolve many substances, especially polar and hydrophilic ones. For example, sugar and salt, when you mix them with water, you're aware of how they will dissolve, right? That is exactly what water dissolving solvents is. In this case, salt and sugar are the solvents. No, yeah, are the solvents. Now, water is polar, as I mentioned earlier. Always remember polar. This will come up a whole bunch of times. And thus, it is hydrophilic. What does hydrophilic mean? This word stems from Latin, and hydro means water, and philic means loving. So if you put these two together, it says water loving. So this means water is attracted to water, right? That's why we have big seas, we have big lakes, all of that, because water sticks to each other. And this causes water to dissolve hydrophilic polar substances. Since these kind of mix, polar and polar mix, non-polar and non-polar mix. It's always like that. Hydrophilic and hydrophilic mix, hydrophobic and hydrophobic mix. So you can think of it if water is polar and hydrophilic, uh, water loving, and it meets another substance, for example, sugar, that is also hydrophilic and polar, it will just dissolve that because it goes kind of together. Now, since water is, and this is the bio behind it, since water is polar, it can form hydrogen bonds with other water molecules, but also other polar molecules which have these unequal sharing of electrons. This law allows for these bonds between the two substances and molecules, you know? Now, water will not dissolve nonpolar substances, as nonpolar molecules do not have the charged region that can form hydrogen bonds with water. You see how these are charged regions that cause these hydrogen bonds. What this is saying that a nonpolar substance will not have this. So it won't be able to cause this hydrogen, to create this hydrogen bond, you know? So don't they have an equal sharing of electrons, because the unequal sharing of electrons causes this charged region, right? If it would be equal, the charge would be zero. That's kind of the logic behind it. That's how I remember it. Now, non-polar molecules are genuinely hydrophobic. Hydro again means water. Phobic means kind of fearing or hating, the whichever way you interpret it. So this means water fearing, and they thus do not dissolve well in water. For example, oil is nonpolar and hydrophobic, and if you put a drop of oil in water, you will notice that it won't dissolve. Hydrophobic substances therefore require a medium to be transported in a watery environment. Now, A1.1.6. This is the physical properties of water and its consequences for animals in aquatic habitats. Now, you need to remember that consequences don't always mean it's negative. It's either positive or negative. Consequences is just something that occurs because of these physical properties. The first one is buoyancy. Buoyancy is the upward force exerted by a fluid on an object submerged in that fluid, which allows the object to float or sink depending on its density relative to the fluid. So, water has a density, right? And this high density of water, water has a relatively high density, gives it a strong buoyant force, which means that objects that are less dense than water, let's say a piece of wood, ice, a leaf, all of these will float on top of water. Many aquatic organisms that are less buoyant than water or less dense, thus can float in water, which is important for them. Now, high buoyancy in water is required as it is crucial for aquatic life. Viscosity is the fluid's resistance to flow or deformation. Water has very low viscosity, and thus it flows relatively easily and quickly. However, water's viscosity is still there. You can think of it as, for example, if you're at the beach or you're in a pool and the water's, let's say, goes up to your hips, you see how if you try to run, it will be extremely hard. This is because of this resistance that water creates, hindering you from actually like running on full speed. So this is viscosity. Now, water's viscosity is sufficient to create some resistance against movement, which I just explained, and organisms in the aquatic environment must overcome this. However, it also enables efficient transport efficient transport of substances within water and organisms, for example, blood circulation. Now, let's go back to the viscosity. Viscosity of air, for example, is way lower than in water. That's why you're running way faster on land because you have less of this resistance on you. Now, the thermal conductivity. This is the ability of a substance to conduct heat. Water has higher thermal conductivity than air. And this means that it transfers heat more efficiently. That's pretty self-explanatory. Now, the fourth one and last one is the specific heat capacity. This is the amount of heat or energy that is required to raise the temperature of 1 gram of a substance, in this case water, by 1 degrees Celsius in Kelvin. The IB will usually use Celsius. Now, think about it like this. You have a water boiler in your home, and if you go to make a tea, coffee, and you just need to boil some water, right? You're gonna have to put the water in the water boiler and you have to turn it on. This will require a lot of electricity and energy to actually get the water to heat up. And this is high specific heat capacity. So, water has this high heat capacity. Thus, it requires a lot of energy to change its temperature. This allows for constant body temperature since it requires a lot of energy to change temperature. This allows for constant body temperature regulation in organisms and a constant body temperature. Now, air has a lower heat capacity, so you can kind of compare it. This means that air heats up and cools down much more quicker than water. This was it for IB Water SL 1.1. Thank you for listening. If you have any questions, please write them in the comments, reach out to me per email, or anything of such. If you're part of AB, you can always come up to me in person. I'm part of the Math Club and I love to tutor. So if you have any questions, just let me know. I'll be now passing the ball on to my tutor friend Enzo, which will teach the HL water content, which you can find under this video. Thank you very much.